Hi, this is Dave Waddell with the King County Hazardous Waste Program, and in this portion of our video we're going to be talking about spill response. If you've got chemicals stored up high like this and they're full of liquids, when you bring in the chemical down and over, there's a chance this thing may tip over and hit the floor. Would you know what to do in case it did? How to respond? Whether you should respond or somebody else should? In our video we'll talk about how to make those decisions and what some basic components of a good spill response plan are. So how do we contend with spills? Well, the first thing is to realize that not all spills are big, and not all spills are what we consider like a classic spill, where something tips over and liquid glugs out onto the floor. Some can be very small, like these mercury droplets, but they can still harm your health. Spills really do come in all shapes and sizes. Some are invisible, essentially spills to the air. A cracked cap, vapors coming out. It's spilled, there's just no way to contain it. Clear liquids in a laboratory setting in particular are always scary. What is it? Is it water? Is it acid? Is it a base? Is it flammable? Is it toxic? There's no way you can tell from looking at a puddle of clear liquid on the floor in a lab. At home, it's probably water. Laboratory could be anything. And the first thing in spill response is you cannot assume it's safe unless you absolutely know what it is because you spilled it. Do not make that assumption. Chemicals are guilty until proven innocent. So if you see a puddle of clear liquid, do a quick test. Find a pH strip, throw it in the water or whatever it is, and see if it turns color. Doesn't turn color? Got a good chance that it may be water. If it turns bright red, it's a strong acid. Bright blue, strong base. Now you know enough to have an idea of how to respond to it, or whether you're even qualified and capable of doing it. If there's a broken bottle nearby, go look at the broken bottle before you start cleaning things up to see what the bottle's label says. The other thing is crystals mean something. If you've got a bottle that's got crystals all over it, something's happened here. This is not normal. It didn't get shipped to you this way. Crystals on a cap are a spill. The chemical spilled up. It didn't spill down. What happened here? Is there a risk? Do you know what the container holds? What else could be leaking? Quite often if you see crystals, it may be more than one compound have been released from their bottles and are reacting at the points of release. And some of these crystals could be potentially explosive. So search for clues before you clean up. Now in the picture here, you've got some things going on. Dark cap with a crack in it, bright orange cap, and an electrical outlet right behind. What does this picture tell you? Well, the cap's corroded. It's probably acidic or basic. Orange caps like this usually mean you have a very toxic compound that's often either corrosive and or flammable in addition to its toxicity. If it can corrode the cap, it can corrode wires. There's an electrical outlet right behind it with wires in it. What's the chances that there could be corrosion in that electrical outlet, which could cause an electrical fire the first time you start monkeying around by putting a plug in it? So you're going to have to check the condition of the electrical outlet. You've got to figure out whether that residue on the bottle is dust or reactants. There's a lot of things you need to figure out. So you see white crystals. What does this mean? Well, the crystals could be rounded, they could be pointed, they could be long, they could be short. Common crystals we see on caps: sodium hydroxide, corrosive; ammonium chloride, non-hazardous; ammonium nitrate, oxidizer; organic peroxides, explosive. Let's look at each of these in some detail. Sodium hydroxide is probably one of the most common crystal forms we'll see in labs. Generally they're fairly rounded and they tend to migrate out of the container and just get all over the place. So if you see a container where the plastic cap or the metal top is corroded through and crystals have completely engulfed the container, it's a good chance it's corrosive sodium hydroxide. Now, sodium hydroxide poses a particular risk to your eyes, so if you touch these crystals or get them on your gloves, for Pete's sake, don't touch your eyes. 15 seconds exposure to this compound can cause permanent scarring to your eye tissue. Okay, what if you've got hydrochloric acid with crystals around the cap? Good chance this is ammonium chloride. Not particularly toxic, not corrosive, not necessarily a big deal. Often you can figure out it's this stuff because you'll see white crystals covering everything in the room. This means two things. One, the hydrochloric acid bottle's leaking, and two, there's an ammonium hydroxide bottle somewhere in the room that's also leaking, because the two of them are reacting. So you can go to the base cabinet, open it up, and there'll be a green cap, ammonium hydroxide, with crystals covering it. Go to the acid cabinet, open it, there'll be blue caps with crystals covering it, and white powder all over the place. Luckily, it's not toxic. Really long, shiny, pointy crystals, especially on a nitric acid bottle, good chance it's ammonium nitrate. Very powerful oxidizer. In the cap on the right, you can see that it's got crystals all around it. We've seen so many of these, we actually call them sombrero bottles. Little eyedropper bottles. The nitric acid has completely degraded the black plastic and has formed these long crystals. Again, this also means ammonium hydroxide is leaking. In the picture on the left, we have a cardboard box with the cap showing. Next photo here, you can see what's inside the cardboard box. What we've got is leaking nitric acid and leaking ammonium hydroxide, and that entire box is impregnated with ammonium nitrate crystals. Very powerful oxidizer. If you've got an oxidizer impregnating an organic compound, what you essentially have is a flash paper syndrome. A match lit to this box, this thing would go up in a split second with a nice big fireball. Not something you want to have on the floor in your laboratory. Nitric is by far the most famous cap eater. 7 to 10 years, nitric's going to eat through its cap. Ammonium hydroxide is another one, sodium hydroxide, and iodine. All of these caps you see here have been degraded over time, and if you bump these bottles, tip them over, the contents are going to come out. So these are essentially spills waiting to happen. I especially want to talk for a minute about iodine. This is probably one of the most common spilled in terms of release to the air type chemicals you'll find in labs. Iodine goes directly from a crystal to a fume form. There's no liquid form in between. It's called sublimation. The fumes will degrade the cap and then get released to indoor air. It eats through plastic very readily. You'll see the cap is starting to get cracks and other types of things. It's incredibly corrosive. If I see rust on door hinges or the metal faucets in the sinks, I'm assuming there's a broken bottle of iodine somewhere in the lab. It's a very profound irritant to your eyes and lungs also. It forms hydriodic acid in contact with moisture, and your lungs and eyes are a very moist environment. One of the things you can do with iodine is you can store the containers in a Ziploc bag. When the bag starts turning brown, then you know the cap's gone bad, but at least now it hasn't gotten out in the lab. Get a new cap, get a new bag, and start back over again. One of the things I always look for when I'm inspecting a lab is things that are trying to get out of their containers. If I see containers that are bulged or corroding, I call it pooched out on the top or pooched out on the bottom, something inside is getting active and is trying to get out of the container. These things are generally pretty active compounds and are often very hazardous. One of the chemicals we get concerned about are the water reactive compounds, and especially the earth metals, sodium and potassium, and not so much lithium, but this particular lab has great examples of kind of the good, the bad, and the ugly about chemicals. So potassium metal is one that can be very, very dangerous. It can oxidize over time and become explosive. And what they did on this one, which doesn't look too old, is they actually purchased it in a very small amount. The chips are really small. They're slightly oxidized, but they're not too old. So the teacher here is probably actually using this up, and it's not posing much of a risk. The sodium, on the other hand, which is also highly water reactive, just a small piece will dance around on the surface of the water and generate enough heat and hydrogen to possibly burst into flames. We've got a whole pound in this can. The can has corroded, which would indicate to me that the sodium is starting to degrade to where I can't open this can up to see what's inside, which makes me very nervous because something that's going to degrade over time and possibly even become somewhat explosive in a can that you can't open is almost guaranteed to degrade over time and become explosive. So this is the kind of thing where when I'm working with schools, one of the things we're looking at is how chemicals are used, how they're being handled, how they're being stored, and how they're being disposed. And if you can't use the chemical and you can't handle the chemical and it poses a risk being stored, then this is a highly likely candidate for disposal, since if he can't get in, he can't use it. If he can't use it, it's going to cause a problem, so let's get rid of it. Now, as a trained investigator, I'm looking for clues about potentially hazardous situations. So here we have another container of sodium metal. It's in a plastic carton, which is pretty bizarre because this is not the shipping container, and the top is pressurized. So the first thing I'm thinking is when I open this, I'm going to open it away from me. And nothing much has happened. And oh my, we have a whole lot of sodium here. There's a couple of things going on here. One is, as soon as I open it, I can smell that this is not oil, which this is normally stored under. It smells like some kind of petroleum distillates, maybe even almost like a gasoline type thing. Also, as soon as I touched the container, bubbles started coming up, which indicates that the sodium metal has reacted at some point in time with the moist air that we have here in western Washington and is degrading. And the other thing I can see is that it's no longer a nice shiny silver color. It's degraded past the white stage of sodium hydroxide into the yellow and orange stage of sodium peroxide and almost into a sodium binoxide. This is getting to the point where if it was potassium and looked like this, we would be calling the bomb squad to deal with this. With sodium, we're just going to make sure that the stuff gets shipped off-site before anybody even tries to use it. And it's at least a full pound and maybe 1.5 pounds of sodium in here. So this is definitely a situation we're concerned about. And this is kind of what we do with the King County Hazardous Waste Program, is come onto a school site and just start looking around with a different set of eyes. Rather than looking at how this stuff can be used, we're looking at whether the stuff even is being used, and if it is being used, how much is being used. Something like this, they're maybe using 1 gram or 2 a year at the most. 454 grams per pound, at least 2.5 pounds here. If he's using 1 gram per year, this is a 900-year supply of this compound. And this chemical is not going to stay stable for 90 years or probably even 9 years, let alone 900. So this is a hazardous situation. It's chemical not being used. Let's get it off-site, and nobody needs to worry about it in case there's an earthquake or something else happens. Or some kid sees the sodium demo and finds the door open and gets back here and steals a whole pound. Because this will detonate and essentially become a bomb if you throw all of this into water. So let's say you found a spill, or you found something that's trying to get out, and when you foolishly open it up to see what was in it, it did indeed get out. How do you respond to it? The recommendation I usually make is to go to the University of Washington's website and look at their spill response guidelines. And the slide here shows a link to their website. You need to be prepared in advance. You don't want to develop your spill plan while you're standing in the spill. You want to have this thing set before you go. So you need to think about what could spill, and any liquid in particular in your laboratory or other school program could spill. What level of training can we commit to in order to respond to this? What if it's a spill that requires you to get into a full self-contained breathing apparatus, wear Kevlar body armor, go through 40 hours of training every year? I'm thinking they're probably not going to want to pay for that for the teachers in your district. So if you can't do that, what outside emergency response agencies are available for you? Know these things in advance. Talk to these people. Coordinate with first responders before it happens. Bring the fire department out to your school and show them what you've got and explain the hazards associated with it and figure out a plan so you know how to get a hold of them. Once you get the plan figured out, get it in writing and then do hands-on training. Actually drop a bottle of liquid on the tile floor and let it break and figure out how do you clean this thing up. It doesn't work well if it's theoretical. It helps if it's practical and you've got some body learning that's associated with it. One of the things to understand with spilled materials is no one can use these unless they're trained in it. So for each of the major hazard classes you have in your school, acids, bases, flammable solvents, and toxics, you need to know how to respond or if you can respond to them. And there's major spills and minor spills. Major spills are ones that cause injury to personnel or are likely to cause injury. They're uncontained and spreading out from the immediate area, endangering other labs or rooms. They've got the potential or have actually started a fire. These are the ones where you pull the fire alarm, you contact 911, you secure the area, and then you evacuate the area that's at risk. The thing you don't want to do is run out of the room and leave the stuff lying on the floor, so when the bell rings, the next class comes in and they all get exposed to the things that you ran away from. Minor spills can be defined on whether or not you can answer yes to these 4 questions. If so, it may be safe for you to clean up the spill. Do you know what was spilled? Do you know the hazards of the spilled material? Do you have a chemical spill kit that can respond to that particular type of chemical spill? And can you protect yourself from the hazards? If you answer no to any of those 4 questions, you cannot clean up that spill. And as far as you're concerned, it's a major spill. The classic example I use for the difference between a major and minor spill is sodium hydroxide versus ammonium hydroxide. Both of them are caustic bases. They're both clear liquids. Have very similar characteristics in that sense. So sodium hydroxide spill, say a 50% solution, you add an absorbent to keep it from spreading, you add a neutralizer, typically citric acid works well to it, stir it in, it'll bubble a little bit. When the bubbling stops, you sweep up the residue, which should be dry by now, Put it in a plastic trash bag, dispose of it in the trash, file an incident report. Ammonium hydroxide spill, you do exactly the same thing, only you have to do it holding your breath with your eyes closed because the irritating vapors that come off of it are unbearable to breathe in or to keep your eyes open in. So now you've got to do all this stuff with a highly corrosive compound that you can't see, and you have to do it really fast because you're holding your breath. So you've got to do it all in about 30 seconds. The first one is a minor spill. The second one is a major spill because you are not equipped to handle that. That's a simple example. There are others. You'll need to figure those out in your own school. So for minor spills, alert the people in the immediate area that there's been a spill so nobody walks through it. Avoid breathing in vapors if there will be any. Put on your protective equipment that you've got, goggles, gloves, protective clothing. Make sure the spill gets confined. If there's a drain nearby, use some sand or absorbent, kitty litter type of thing, and get it between where the spill has happened and where a drain is or a door. For acids and bases, you neutralize it with baking soda for acids or citric acid for bases. Baking soda does help with bases, it just takes longer. Collect the residue, put it in a plastic bag, dispose of properly. For other liquids, absorb with vermiculite, dry sand, or absorbent pads. Collect the residue, put in a plastic bag, and dispose of properly. Proper disposal is covered in the hazardous waste section of this training. And then once you've cleaned all that stuff up, clean the spill area with water. So in case there's a very slight residue, it gets mopped up. If it's a mop, dispose of that mop head afterwards. It's probably not seriously contaminated, but why take that risk? Major chemical spill procedures, avoid becoming a casualty. Get out of there. If somebody's gotten injured in the area, don't go in to try to rescue them. This is one way to create a stack of additional victims. Firefighters just hate it when people do that. Alert people in the area to evacuate. If it's flammable, get the ignition sources turned off if you can. Close the door to the affected area. Call 911. Have somebody who knows what was in there stick around the building and talk to the responders so they're not going in blind. But these things need to be refined, and it needs to be done in coordination with your emergency responders. So in the picture I've shown here, on the left side, is this a major or minor spill? Is the right side major or minor? What information do you need before you proceed? Is she taking a nap underneath that counter area over there? Or is she down because she's been injured? Maybe she's looking at something really closely. Who spilled the bucket? Do they know what's in there? How come there's a footprint in that residue that's on the floor? Basically, you got to be prepared. Practice your drills so you don't panic when you get in these type of situations. If you have any questions about these spill procedures, feel free to contact me. I can be reached at dave.waddell@kingcounty.gov. Thanks.